Hello AP Physics students, it's Mr. Ellis, and in this video I'm going to show you how to solve one of these problems with charges arrayed in two dimensions where you have to add vectors. I noticed some issues with this on the WebAssign and in class, so I think this will be helpful for you guys. I'm going to start by putting the charge that we're interested in, this -2 microcoulomb charge at x equals 2, y equals 2 on there. Okay, so the first step in these problems is to just crank out the math and find the magnitude of each force. But it is helpful to look at the picture in this case because you need to know the distances, like the distance between each charge. So this is 1 meter. This distance is also 1 meter. But this distance here, since you have a 45, 45, 90 triangle, is going to be the hypotenuse, which is 1 squared plus 1 squared square root of 2. All right. So what you just have to do is crank through the math, right? So I do this 3 times so that you want to know the force of the -3 charge on the -2 charge that I put on there. So that's going to be, K times -3 E -6 because it's microcoulombs, -2 E -6 over R squared, that's 1 squared. Now, the sign that this spits out is not very useful. You're going to need to actually look at the picture to figure out what direction this is. So what you get when you do the math is 0.054 newtons. But the question is, where does that go? So they're both negative, right? So this -2 charge should be repelled by the other same charge. So this is in the positive x direction. Okay. Similarly, you're going to do all the other ones. 4 on -2, when you do the math, you get 0.072 newtons. What direction is that? Looks like it's going to attract it, right? So that's down. So we'll say that's in the -y direction. And then the last one, be quiet, rain stick. The last one is 2 on the -2, positive 2 on the -2, and you get 0.018. Now this one, they're going to attract, this force goes down and to the left. So it's got some -x and -y. Okay? The problem there is when you want to add the vectors, you're going to have to split that up into 2 parts. So let's figure out how much of that is in the x direction and how much is in the y direction. So it might help here if I clean this up a little bit. Now we have our force vectors, which are not the same as the displacement vectors that were also drawn on there. So this is your F2 on -2. All right, so this has 2 parts, right? It's got an x part and a y part. There's an angle. That angle is 45 degrees. So this is your x, right? So in order to do that, you just have to do some trig. It's going to be, the magnitude times the sine of 45 degrees. So this one's going to be 0.0127, and the other one is also 0.0127 because sine and cosine of 45 degrees are the same thing. So once you know those 2 parts, when you add vectors, what you're going to do in the end is add up all the x parts separately and all the y parts separately, keeping in mind their signs. So in this case, there's an x right here, 0.054 newtons in the positive x direction, and then this guy is in the -x. Oh man, -x. And that minus 0.0127 as a result. In the y direction, we've got a -y and another -y, right? That's this one's in the -y direction. So the last part of this problem should look pretty familiar. Once you found the net force in the x direction and in the y direction, then you're just finding the resultant vector. You're adding those 2 vectors to get the actual magnitude and direction of the net force. So once you've drawn it, you can see kind of what direction it goes. Then you use the Pythagorean theorem right here to solve the magnitude and the inverse tangent to find the angle. On WebAssign, sometimes it asks for the angle from the x-axis, so just be aware that if you're south of the x-axis, you need to go all the way around in the positive direction to get the angle. All right, thanks for watching.